Our idea mainly consists of four sections. First is entering or updating the patient using RFID. In this section, we assign to or read the RFID of the patient. After fetching the unique ID from the RFID tag, the doctor will compute to give the total dosage. He can also set the frequency of the dosages, that is morning dosage, afternoon dosage and evening dosage. After course completion, the patient is examined by the doctor and he and she is cured, then the doctor will delete the entry from the database. Also, there can come an instance to refill the Medibot. For this, the doctor or the compounder can enter the medicines and update the stocks. Last is to access the patients. Medibot will go to the patient will tap onto the RFID and verification is done and our database is checked for the time and dosages. Dispatching is done through the medicine dispatching mechanism and database is updated. So this is the Medibot which works on Raspberry and it comprises of a 16 by 2 LCD module to display, RFID reader to read the tags, and a numeric keypad to get raw inputs. Furthermore, we have two motor drivers which drive the three motors below. Now coming on to the dispatching mechanism, we have three aluminum coils attached to the motor via disc. Locking is done by the servo motor. Closed loop system is achieved by the ultrasonic sensor. This is the top view for refilling with sliding compartments. This is our arena with nodes N1, N2 and N3. So here we have 6 tables: patients, Med A, stock, Med B, Med C and doctors. Patients consist of ID, RFID, total dosage. Med A consists of ID, morning, afternoon and night sequence. Stock consists of name and amount. And doctors consist of ID, RFID and name. As suggested in the recommendation letter, two-step verification was to be implemented. But since the SQL doesn't accept two primary keys, and also the fingerprint sensor was granting access to any patient irrespective of the unique ID. This is not acceptable when it comes to real-life applications. Also, the output of the fingerprint sensor had ripples and wasn't clear enough to distinguish. Therefore, the fingerprint sensor was difficult to implement. Completion status of our team is as follows. Creating the patient entry. We were able to create a new patient entry with unique RFID and auto-incremented patient ID. Modification and update is possible. Whenever the doctor wants to prescribe a new set of medicines, he can update the database with new set of frequencies of dosage delivery. Verification of registered patient and doctor is possible. Verification is done by mapping the incoming input with the existing entry in the database. This was achieved successfully. Dispatching the medicine successfully. We were able to dispatch the correct number as well as the correct type of medicines to the patients. This forms a closed loop system. Couldn't achieve two-step verification process. This is the only drawback of the system till date. Why should our ideas be selected for finals? First of all, according to the recent study, the increase in the number of TB patients is at red alert. This demands for the research for the main cause of transmitting, which happens to be the contagious nature of the disease. Even doctors who diagnose TB patients were found to be infected with TB. This is where the Medibot comes into the picture. Medibot not only limits the human interaction with patients, but also works 24/7. The Medibot can be used as a vending machine in remote areas where availability of doctors is less. Traditional method, that is pen and paper method, can be omitted out in the digital world, and it is cost effective too.